Hi everyone, in this video we are going to see about the speed control of DC motor. The speed control is the essential one for the DC motor. For this we can come from the equation that is N is directly proportional to EB by flux, that is speed is directly proportional to back EMF and inversely proportional to flux. From this equation we can see that the speed can be controlled by varying the flux or resistance or the applied voltage, that is flux control method, rheostatic control method or applied voltage by varying the applied voltage. First we see the speed control of shunt motor, that is variation of flux or flux control method. From this diagram it is observed that field is controlled with the help of rheostat, that is increasing the field resistance decreases the field current, because IF, that is field current, is inversely proportional to the field resistance. While decreasing the field current, it decreases the flux. Decreases the flux, increasing the motor speed, as we see that N is directly proportional to back EMF and inversely proportional to flux. So by decreasing the flux, the motor speed gets increases. This can be done inversely by decreasing the field resistance, the same process to decrease the motor speed. This is the flux control method. And the second one is armature or rheostatic control method. The same principle what we have seen in the flux control method, here we are done with the armature side. That is, we are using the rheostatic method in the armature to control the armature current. In this method, when the speed below the no load speed, this method is required. By decreasing the armature voltage, it decreases the back EMF. So back EMF decreases the speed, as the equation represents N is directly proportional to back EMF. And the third one is voltage control method, multiple voltage control. In this method, shunt field is connected to a fixed exciting voltage and armature is supplied with different voltages. Basically, we are supplies the voltage is supplied to the field as well as the armature is same, but here the method is multiple voltage control. So we are supplying a fixed voltage to the shunt field and the another different voltage to the armature. Voltage across the armature is changed with the help of suitable switchgear. The speed is approximately proportional to the voltage across the armature, but this method is not used much for speed controls. And the next one in the voltage control method is Watt Leonard system. This is the one of the important speed control techniques for DC shunt motor. In this system, very sensitive speed control is achieved. For example, electrical excavators, elevators, etc. Here in this setup, we are using two motors M1, M2 and a generator is required. We will assume that motor M1 is the motor to which the speed control is required. M2, that is another motor, may be a AC motor or it may be a DC motor which runs with a constant speed. G, generator is directly coupled to the motor 1, that where which the speed control is required. In this, the output from the generator is fed to the armature of the motor M2, whose speed is to be controlled. The output voltage of the generator can be varied from 0 to the maximum value by means of its field regulator. That is, generator field is controlled, so the speed can be varied with the help of generator. The armature voltage of the motor M2 is varied smoothly, hence the speed control of the DC motor can be obtained by this method. Next, we will see the speed control of series motor. In that first one, field divert flux control method, we are having two methods. First one is field diverters, second one is armature diverter. In this, first we will see the field diverter. As we know that in DC series motor, the armature and field is connected in series. In that, field is diverted with the help of resistance, which is known as field diverters. A variable resistance is connected in parallel to the series field. This variable resistor is called diverter as the desired amount of current is diverted through this resistor. Hence, the current through the field coil is decreases. So the flux get decreases and the speed will get increases. In second one, it is armature diverter. In this, the diverter is connected across the armature for a given constant load torque. If the armature current is reduced, then the flux will increases. That is, TA is directly proportional to IA into flux. This will result in increase in current taken from the supply. So the flux will get increases. The speed of the motor will get decreases. Second one is variable resistance in series motor. That is, by connecting the rheostat in the series field is known as variable resistance in series. By increasing the resistance in series with the armature, voltage across the armature can be reduced. With the reduced voltage, armature speed is also reduced. However, full motor current passes through the resistance, so there will be a loss of power. And the next one is series and parallel operation of DC series motor. In this, system is widely used in electrical traction where two or more mechanically coupled series motors are employed. For low speeds, the motors are connected in series, and for higher speeds, the motor are connected in parallel. When in series, the motor have the same current passing through them, although the voltage across each motor is divided. When in parallel, the voltage across each motor is same, although the currents get divided. Thank you.